Okay, welcome to the Aspirant Academy. Myself Sidharth. I'm going to give a lectures on second year course, electric charges and electric field, like that. Okay, first chapter. So what is electric charges and electric field? First chapter, electrostatics. In our electrostatics, there are basically three chapters in your higher secondary second year. So first of all, one is called electric charges and its properties. Next is called electric potential and electric current. These are three chapters very important for your exam point of view. So first of all, in this first chapter, I am going to discuss about electric charges, and field. So this is an important chapter for the first year, second year students. So here what is electric charge? So basically what is electric charge? It is an intrinsic property of the matter. So electric charge is a intrinsic properties and it is denoted by small letter q or capital letter q. This is capital letter q or small letter q. So electric charge are two types. Charge are two types. Number one is called positive charge and another one is called negative charge. So positive charge is called proton or negative charge is called electron. So there are two types of charges, positive charge and negative charge. So positive charge is called proton or negative charge is called electron, or also it can define as positive charge or E plus or negative charge is called E minus. So charge can be divided into two types. It can be positive charge and negative charge, proton or electron, E plus or E minus. So one charge is a one value of charge. So what is the value of one charge? Either it may be positive or negative. Either it may be positive or negative. So it is called, what is the value of one charge? We know that 1.6 into 10 to the power minus 19 coulomb. So this is very important. So what is the one charge value is 1.6 into 10 to the power minus 19 coulomb. So basically what is the SI unit of charge? Charge, the SI unit of charge we can call small q, basically is called coulomb. It's called coulomb. So there are various things to remember. So first of all, two charge, positive and negative, electron and proton, positive E plus or E minus. So one value of charge is called 1.6 into 10 to the power minus 19 coulomb. So one charge SI unit of charge is called coulomb. So these are the basics of electric charges. So now, electric charge is positive and negative charge, and these are some properties are there. So some properties of electric charge. Some properties of electric charge. Number one is called attractive property and number two is called repulsive property. So there are two types of properties called attractive property and repulsive property. So attractive property, what is called attractive property? So first of all, what is called attractive property? So what is attractive property? So when the two charges will be attract, suppose one charge is called positive charge and another one is called negative charge. So they can attract each other. So what is the definition of attractive charges? Two dissimilar charges attract each other. Means one positive charge and one negative charge can attract each other. This is called attractive property. Another one is called repulsive. What is called repulsion? Repulsive. So what is repulsive property? So there are two similar charges can repel each other. Okay, similar charges means suppose one called positive charge, suppose Q, and another called positive charge Q, they can repel each other. They can repel each other. And another negative charge minus Q and minus Q, they can repel each other. So this is repulsive property. So attractive property and repulsive property. So next one. So very important thing is called attractive and repulsive property. So after that, some basic properties of electric charge is there. So what is basic properties of electric charge? So this is very important. So basic properties. So what is the basic property? Number one is called additivity. and number 2 is called quantization, and number 3 is called conservation. So there are 3 types of properties, basic properties. Earlier one is called at properties only, and this is the basic properties of electric charges. So what is basic properties of electric charges? First of all, additivity, next one quantization, and third one is called conservation. So first of all, what is additivity? So basic properties of electric charge, additivity, quantization, conservation. So first of all, what is additivity? Suppose we have a system. Suppose this is a system. Suppose this is a room. In a room, we can consider is a system. So in a system, suppose several charges is there. Suppose this is Q1 charge. This is suppose Q2 charge. This is Q3 charge. This is Q4. This is Q5 charge are there, and this is suppose Q6 charge. So according to the additivity property, how can we add these things? So first of all, what is total charge? Q1 plus Q2 plus Q3 plus Q4 and Q5. So these are the 5 charges. So we can add all the charges, and this means there is additivity property. So what is additivity? Suppose in a system, suppose these are the charges are there. So Q1 charges, Q2 charges, Q3, Q4, Q5 and Q6. This is a countable number of charges. So in this countable number of charges, we have to in this properties, we have to first add all the charges, and this means this Q is equal to Q1 plus Q2 plus Q3 plus Q4 child dot 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 dot. These are included the additivity property. So next is called conservation of electric charges. So next one is called conservation. Quantization. So quantization means suppose in our bulb, suppose what is the mechanism of a bulb? It emits lots of electron. What is electron are there? We can uncountable number of electron can emit. So what is the total charge inside a bulb? Suppose in a conductor, then uncountable number of electrons are emitted here. So we cannot calculate it with the help of additivity property. So with the using small formula is called according to quantization of formula. So quantization Q is equal to NE. This is includes in the quantization of electric charge. So Q is equal to what? Total charge, N is the called number of charge. So this is called E is the value of charge is called what? We have already discussed 1.6 into 10 to the power minus 19 coulomb. So this is all about the quantization of electric charge. Q is equal to NE. From this formula, we have to also calculate number of electron. We know Q is equal to NE. So N is equal to what? Q by E. According to this formula, we have already derived. We can derive the total the charge and what number of charge. So this is about the quantization of electric charge. So next one is called, this is very very obvious thing. It's called conservation of electric charge. So what is conservation of electric charge? Conservation of electric charge is this: a charge cannot be created nor be destroyed. It can transfer from one place to another place, or one point of a conductor to another point of a conductor. So this is called what? Conservation of electric charge. So additivity property, quantization and conservation. What is quantization? Quantization we have already discussed. Q is equal to NE, and conservation is called energy cannot be created nor be destroyed. It can transfer from one place of form to another place. So now we have to discuss some numerical problem regarding the quantization of electric charge. So first of all, we have to discuss some formula. So what is some numerical we can discuss according to this quantization of electric charge. So first of all, question number 1, first question. So first question, a comb drawn through person's hair on a dry cause 10 to the power 22 electrons to leave the person's hair and stick to the comb. Stick to the comb. Calculate the charge carried. The charge carried by the comb. So a comb drawn through the person's hair on a dry causes 10 to the power 22 electrons to leave the person's hair to stick in the comb. Calculate the charge carried by the total charge carried by the comb. So here what is the thing is there, 10 to the power 22 electron. How can you solve this numerical? So first of all, so given n is equal to what, 10 to the power 22 electron. We know that E always constant, 1.6 into 10 to the power minus 19 coulomb. So after that, what is Q? Q is equal to, we have to calculate. So Q means what is total number of charge. So what is total charge? So Q is equal to, we know according to the quantization condition, Q is equal to what? Q is equal to NE. So Q is equal to N means what? 10 to the power 22 into 1.6 into 10 to the power minus 19. So after calculation, 1.6 into 10 to the power 3 coulomb. So this is the total charge inside the comb. Okay, so how we can proceed this one? We know that according to the quantization condition, we know Q is equal to NE. From this formula, we have to calculate the total charge inside the comb. So have you got my point? So this is the total charge, 1.6 into 10 to the power 3 coulomb is the total charge inside the comb. Okay, how we can proceed this one? Okay, next one. So next one, which is bigger? This is very important thing. This is very important. Which is bigger? Which is bigger? A coulomb or a charge on an electron, which is bigger, a coulomb or a charge of the how many electrons from 1 coulomb of charge. So which is bigger, a coulomb or a charge on an electron? How many electrons from the coulomb of the charge? So which is bigger? First of all, which one is bigger? First of all, how can you solve this equation? First of all, which is coulomb? 1 coulomb. So Q is equal to, suppose 1 coulomb or a charge on an electron. Or a charge on an electron means what? Charge on an electron means, we know, minus 1.6 into 10 to the power minus 19 coulomb. In a 1 electron, what is the total number of charge? 1.6 into 10 to the minus 19 coulomb and 1 coulomb. Which is bigger? Obviously 1 coulomb is more. 1 coulomb. So 1 coulomb here, 1 coulomb is more. This is bigger. Then how many electrons from 1 coulomb? So here, how many electrons from the electron? We have to calculate, and now we know that Q is equal to 1 coulomb. So how many electron? Again, according to the quantization condition, Q is equal to NE. Q is equal to NE. So how can you calculate Q is equal to NE? N is equal to how much? Q by E. So Q is equal to what? 1 by 1.6 into 10 to the power minus 19 coulomb. So according to this one, we have to calculate, after calculation, 6.25 into 10 to the power 18. This mass of electrons are generated in 1 coulomb. So this is the question. The question is what? Again I will repeat. So which is bigger, a coulomb or a charge? A charge or a coulomb, which is bigger? Obviously, Coulomb, Q is equal to 1 Coulomb, or a charge means in one charge, what is the value of one charge? 1.6 into 10 to the power minus 19 Coulomb. So here 1.6 into 10 to the power minus 19 Coulomb is greater or 1 Coulomb is greater? Obviously 1 Coulomb is greater. And after that, in next question, how many electrons from 1 Coulomb of the charge? How many electrons mean? We have to calculate num n. How many electrons? So this formula is coming from what? Quantization of electric charge. So according to that, the quantization of electric charge, and Q is equal to Ne. Now we have to calculate what? M. N is equal to Q by E. After placing these values, so 1 by 1.6 into 10 to the minus 19. After that, we are getting what? 6.25 into 10 to the power 18 electron. Sorry, this mass of electron we can generate it. So this is the solution of this equation. So this is a problem. After that, so this type of numerical, there are lots of numerical in our book. So you can solve accordingly. So now after that, so conservation is over. After that, a new thing is called, very important one, very important. Very important one. Okay. Next one is called Coulomb's law. This is very important. Coulomb's law. So first of all, what is Coulomb's law? Coulomb means the one scientist who can discover Coulomb's law. So Coulomb's law is nothing but the force of attraction between the two charges. So what is the total force? How the force can be calculated with the help of two charges. So suppose one charge is protons and another electron. One proton and electron, they can what? Attract each other. In attraction, their attractive force will be developed. Is it? Attractive force will be developed. Suppose after that, suppose these are dissimilar charges. So these are dissimilar charges will attract each other. So in attraction, two forces will generate, one forces will generate, that this force is called attractive force, obviously. So suppose we can consider this is suppose positive Q charge, Q1 charge suppose, and another one, suppose this is negative Q2 charge is placed here. Okay, so in a distance R, distance between the two charges, we already know according to the according to the attractive and repulsive property. So what is attractive property? Dissimilar charges attract each other and similar charges repel each other. So if the two dissimilar charges are placed here, so they can attract each other. So in attract each other, the attractive force will be generated. Suppose in this case, another one case, suppose this is the positive Q1 charge and another, suppose these are the what? Positive Q2 charge is placed here with a distance suppose R. So in this case, the repulsion is produced. They can repel each other because they are similar charges, so they can repel each other. So if it is repel each other, then what is the force here? This force is called repulsive force. In this case, this is the main basic diagram. In this case, Q1 and Q2 are the two charges. They can opposite charges. So one is positive charge and another one is negative charge. They can what? Attract each other. So attractive force. Attractive force will be generated. Okay. So attractive force, in this case, force will be generated. This is repulsive force. Similarly, suppose this is Q1 charge, positive, negative charge, and this is another Q2 negative charge. Distance between this is R1, R. They already taken. Repulsive force will be developed. Yes, repulsive force will be developed. So in this case, suppose we can take only one diagram. So in this case, what will happen? The attractive force will be developed. So according to the Coulomb's law, so what is attractive? So according to the Coulomb's law, that this force of attraction and repulsion is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So here, so what is the main thing? Which stress this? Coulomb stress this first, force of attraction and repulsion, force of attraction and repulsion is directly proportional to the product of the two charges, product of the two charges, and inversely proportional to the square of the distance between them. So for what is Coulomb's law? In Coulomb's law there are two types of force will be generated. So one is called attractive force and another one is called repulsive force. In attractive force, what this attractive force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So this force is directly proportional to what? According to this statement, product of the two charges mean Q1 into Q2, and inversely proportional to means what? Is inversely proportional to the square of the distance between them. So if you consider this is equation number 1 and this is equation number 2, after combining what is force? F is proportional to what? Q1 Q2 by R square. Then F is equal to one constant is coming out, K Q1 Q2 by R square. So according to this formula, so what is Coulomb's law? According to this formula, K is equal to Q1 Q2 by R square. So this is all about what? Coulomb's law. So first of all, what is the statement? Coulomb's law, according to the Coulomb's law, it states that the force of attraction and repulsion is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So this is called Coulomb's law. So what is the formula after getting this expression? F is equal to K Q1 Q2 by R square. Now what is K here? K is a constant. This K is after calculation we can 1 by 4 pi epsilon naught. This is a constant and this value is equal to what? 9 into 10 to the power 9. 9 into 10 to the power 9 Newton. 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value. So what is epsilon naught? This epsilon naught is called permittivity in free space. So permittivity in free space. So now the Coulomb's law is looking like that. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is called famous Coulomb's law. Any problem? So this is called famous Coulomb's law. So this Coulomb's law states that the force of attraction and repulsion is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So next one. So next, according to this one, after that, it may be asked that in exam it may be asked what is the vector form of Coulomb's law. So next one, vector forms of Coulomb's law. Vector forms of Coulomb's law. Next one is called vector forms of Coulomb's law. So according to vector forms of law, we can represent as a vector. Suppose two charges, one is called positive Q1 charge and another one suppose two charges Q2 charge. What will happen? They are positive charge. These are positive charge, so they can repel each other. So repulsion force will be developed in this way, and another repulsion force developed in this way. this is the distance between the two charges is called R. So here, this is a Q1 charge, this is Q2 charge. What is the force here? Force will be F12 here, and this in this side, two charge G2 T1, this is called F21. So these are two forces will be developed here. So after that, so this is a vector. So one direction is there. Direction is called R cap. R cap here what? R cap is all 1 2 in this direction, and another one, this one R21 cap. Okay. So now how can you proceed according to the vector school of Coulomb? Now we can express f of 21 vector f of 21. We can represent what is a vector f of 21 is what? Vector symbol, vector type of force on what is 21? Force on charge Q2 due to Q1. So how we can represent force is we know already. We can calculate this one 1 by 4 pi epsilon naught Q1 Q2 by R square. So what is the direction here? Direction is equal to R12 cap. For f of 21 is equal to what? What is that? This one direction from here to here direction. So after that, f of 12 means what? Force on charge Q1 due to Q2. So this is force of charge Q2 due to Q2. So how can we represent f of 1 by 4 pi epsilon naught Q1 Q2 by R square R21 cap. So this is the vector forms of Coulomb's law. We can represent vector in this way. We can represent vector. So vectorically, how we can represent the Coulomb's law? So Coulomb's law is nothing but a what? We already discussed this is Coulomb's law. So now how we can represent this Coulomb's law? So this is that we can represent two charges will place here. These two charges are the positive charge. This positive charge then repulsion takes place. The force will be in this direction. This force is F12 means what? F12 means force on charge Q1 due to Q2, and here F21 means what? Force on charge Q1. So we know F1 vector. So we know what is vector quantity first. So vector quantity, those who have magnitude as well as direction. So vector, so magnitude is, this is the magnitude 1 by 4 pi epsilon Q1 Q2 R square. This is the from the Coulomb's law. And what is the direction? So direction of this force is what? Direction of this force, this one direction R12. That's why we can represent R12. After that, this force F12 here in this what is direction? F12. This is the famous Coulomb's law, and this is the vector forms of Coulomb's law. Okay, thank you. This one, the next one. Next what? Dielectric constant, or in this chapter, dielectric constant or relative permittivity This is very important thing. Dielectric constant or relative permittivity. So what is called, first of all, what is dielectrics? So dielectrics means suppose we know this formula is a force is equal to what? 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the which medium? First of all, this force, this is which medium this force will be created? Vacuum, obviously. This force is valid in the vacuum only. Okay, because 1 by 4 pi epsilon naught is the what? Permittivity in the free space, 1 by Q1 Q2 by R square. Suppose the two charges will place in the suppose medium, whether it may be water, air, gas, anything else. Suppose two charges are placed in the two medium, then is it that F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square? No, because it will change. either maybe decreases, some increases. So this topic is called dielectric constant or relative. That's why it is come as dielectric constant or relative permittivity. So dielectric constant or relative permittivity, suppose two charges in vacuum, according to the Coulomb's law, according to the Coulomb's law, according to the Coulomb's law, Q1 charge Q1 and Q2 are at vacuum. Suppose vacuum are at vacuum, then what is the force? F vacuum, we can write I vacuum 1 by 4 pi epsilon naught Q1 Q2 by R square. This is equation number 1. And if Q1 and Q2 are at suppose medium, any medium like air, water, like that. So what is the form force? F medium. So what is F medium? 1 by 4 pi. There is no epsilon naught here. Here this is called epsilon, and this epsilon is called absolute permittivity. The epsilon Q1 Q2 by R square. So what is epsilon naught? Permittivity in free space. Permittivity in free space. Now epsilon is equal to what? Absolute permittivity, just permittivity, or it is called absolute permittivity. So this is equation number 2. Now equation 1 divided by 2, what will happen? F vacuum by F medium is equal to what? 1 by 4 pi epsilon naught Q1 Q2 by R square. This is another 1 by 4 pi epsilon Q1 Q2 by R. This one cancel. This 4 pi cancel. After it is getting what? Epsilon by epsilon by epsilon naught. So after that, after calculation, we are seeing that F vacuum by F medium is equal to what? Epsilon by epsilon naught. This represent, which is considered as kappa or epsilon r. This kappa is called dielectric constant, and this epsilon are called relative permittivity. So this is all about the what? How we can represent, suppose two charges are placed in suppose medium, then how we can represent the force. So now after that, F vacuum by F medium is equal to what? Epsilon by epsilon naught or kappa or epsilon r. This kappa is called as dielectric constant. So this is all about the dielectric constant or relative permittivity. So we know that after that we can represent these things two formula. We can represent that F vacuum by F medium is equal to what? Kappa. So because this is a dielectric constant. So now what is the formula for medium? Suppose we have to the two charges we are placed in a medium, suppose air, water, like that. So what is the Coulomb's law in suppose this one F vacuum in medium, F vacuum by kappa. So F medium by what? 1 by 4 pi epsilon naught kappa Q1 Q2 by R square. So this is the Coulomb's law if we placed the two charges in medium. So this is all about the today's classes.